Hi everyone, I'm Mehul. I'm going to explain my project that is based on query time optimization using Hungarian algorithm. The purpose of this PPT is that I will be explaining the problem statement, the motivation behind it, introduction, the overall system diagram, proposed modules that are used to implement this project, results, application and benefits, hardware and software requirements, conclusion. So, as we all know that data is generated every second exponentially, we need to store it, otherwise we will lose it. So, in traditional in traditional systems, what happens is you take a data set, insert it into the database server, and takes time, right? And the time we have to minimize it. So, what I am doing here is I'm using query optimization in processing time by decomposing the data in hypergraphs based on correlating features and then using Hungarian algorithm and genetic algorithm for its faster transaction time. So in a database server, low performance is cannot be handled, or say let's say handling heavy queries or traffic at the database server results in low performance. And so, if we provide a solution with the fast processing of query, it will save time and enhance the application. So, in system overview, I'm taking a data set, forming it into graphs, then using my algorithms and the model. I am generating a optimized query plan. Now, let's say I am downloading the data set from Kaggle website. You and this project is generalized, so you can put any kind of data set into this. Now I'm using this data set and converting it into graph that leads to graph formation. What is a graph? Graph relates the data item in the store to a collection of nodes and edges. Also, I'm converting these graphs into hypergraphs for the simplicity of this project, because for the KNN it is useful. So what is hypergraph? Generalization of a graph in which edge can join any number of vertices. Now I'm using KNN algorithm. Now what is a KNN? K nearest neighbor, as you will all know. So it is a supervised classification algorithm that will give new data points according to the k number or closest data points. I'm putting the k value as 6. You can use any other value or greater value than that. I did not put because my system was crashing, but if you have a good performance laptop or PC, you can surely use it. So the output of this algorithm is segregated query clusters. So these segregated query clusters go to the Hungarian model and it is processed, and we find that so let in layman's term, let me explain you. Like suppose you own a business and you have three employees to choose from to complete three jobs you need done. So what this algorithm will do, it will find the minimum cost when assigning activities based on cost, and each activity must be assigned to different person. And the output of this will be a query plan that will be provided to genetic algorithm. Now in layman's term, let's say a genetic algorithm creates population. Now like if you already have a population, it will generate more. So what it does basically is it creates random changes in the path or population to generate new paths. Now, so what the Hungarian model will do, it will give a path. Now what will genetic will do, it will create changes, or it will just permute this combination of path. And like suppose you have ABCD, the path is given ABCD. Now the genetic will take all the combinations like D at the first place, or B, or maybe C, and it will see the lowest time to execute it. So it will take that path and will give us the optimized query plan. Now I have implemented modules in this project. So first module is feature selection. Like it takes the input data and process it by selection of attributes and give the attribute vector. Uh, the module B is hypergraph formation. As I said, it takes the attribute vector, creates node and edge, and forms a hypergraph. Now, before proceeding ahead, let me show you an implementation for better understanding. So, let's go to, sorry, let me see if the database is connected. Yeah, so I have already connected MongoDB to the local host. Now refresh it. So um, there is no database currently. So let me open my project. Let me run this. Yeah. So first we will take the path of traditional system. How much insertion time it takes. So let me go to this. No. You can put any other data set if you want. It will insert it. So it has 989 rows. It takes 2196 milliseconds to insert. Now let's see if the database has it and already inserted. So yes, it has been inserted. Now let me delete it so that we can use the optimized path and insert it. Let me close this and rerun it. So I'm running it now with, again I have to browse it and yeah, mark performance session. Now here we see that rows are same, but the timing is different. Before it was taking 2000 milliseconds. Now it is taking 1400 approx milliseconds, which is a significant amount of difference if we have a large data set. Now let me also show you the intermediate results that are generating. So these are the clusters that are forming and the path that is generated and the total time that it calculates, and the minimum time is taken and the rest of the time is just discarded or that path is not effective. So that is how it works. Now let me get back to the PPT. And yeah, so as I was saying, uh, third module is KNN algorithm. So it takes the hypergraph, graph dependency attributes, and it forms clusters by evaluation of distance, and it gives segregated query clusters. The next is Hungarian genetic model. What it does, it takes the clusters and the time and selects the query. Now, after this query generated, again, as I said, the genetic model will work and give a final optimized segregated query cluster, which we will be processing. So that's how we get the clusters. And once we get the cluster, we put it into the server, and it gives the optimized time that is better than traditional system. So this is the without optimization, and this is the with optimization. I'm showing just the 4 data sets. You can put any data set there. Now I'm also representing the result in the tabular form. Like this is an average of 5 times. Like every time we run the data set, it will give different time. So as you saw, that this optimized system demonstrate to be much faster than the traditional system. My system shows on an average 54% of optimization than the traditional system. This graphical representation show the observations done in this project. And so let's go ahead. The application and benefits. Uh, we can use this project in many applications like web applications or data centers where we have real-time data coming every time and with better velocity in huge volumes. What are the benefits? It is cost effective, obviously, because all the softwares are free and open source. And the time saving, I just demonstrated you that it is saving a significant amount of time. Now these are the hardware and software requirements. So if you have a better than this is the minimum or recommended, but you can use a better one if you have, and it will just run smoothly. So this is just a snapshot of the output I have inserted before, and yep. So uh, like proper scrutinization of the dataset attributes will help, and a formation of hypergraphs will result in a faster query. Then query cluster scheduling is important, as I explained in this PPT. So this will generate a query time optimization at the end and will give a better plan than the traditional system, which will help us to save the time. Thank you very much. Let me know if you have any questions by commenting, I guess.